Let's talk about this number, 5,555. I noticed that they're all the same digit, but each digit has a different value. For example, this 5 is in the 1 spot, so its value is 5. This 5 is in the tens spot, so that value is 50. This 5 is in the hundreds spot, so its value is 500. And this 5 is in the thousands place, so its value is 5,000. Do you notice as I move from right to left, these numbers are getting bigger? And there's actually a pattern. Do you see it? When I move from the ones place to the tens place, it's multiplying by 10 or getting 10 times bigger because 5 times 10 is 50. Same thing when I move from the tens to the hundreds, I'm getting 10 times bigger. And when I move from the hundreds to the thousands, 10 times bigger, because 500 times 10 is 5,000. I wonder if that same pattern would ring true if I chose numbers less than 1. So let's just go ahead and put 5s in here. This is after the decimal point. This 5 is worth 5 over 1,000, or 5 thousandths. This 5 is 5 over 100, or 5 hundredths. This 5 is 5 over 10, or 5 tenths. I want to see if this pattern continues as I move right to left. Do the numbers increase 10 times? Well, one way to do that would be to take this number, 5 tenths, and multiply it by 10. And if you're not sure how to multiply by fractions, that's okay. I'm just going to show you that it does work. 5 times 10 is 50, and 10 times 1 is 10. So that's 50 over 10, which simplifies to 5. And that's what I got, so I know it works. Let's try 5 over 100 times 10. That's 50 over 100, because when we multiply fractions, we multiply straight across. That equals 1/2, or 5 tenths. Well, that's what I have. Let's try the last one, 5 over 1,000 times 10. Well, that's 50 over 1,000, and I know I can divide by 10 to get 5 over 100, or 5 hundredths, and that's what I have. So when I move from right to left, the value increases 10 times. So I know what you're thinking, Mr. Hazel, when will I ever use this in real life? I'm so glad you asked. Here's a real life example. A manufacturer made 7,234 boxes of coffee stirs, and each box contains 1,000 stirs. So how many stirs did they make? Well, if they have 7,234 boxes, and each box contains 1,000 stirs, that sounds like a multiplication problem to me. And instead of coming over to the side and multiplying, there's a different way that we could solve this problem using the place value chart. So if I know I'm multiplying by 1,000, I know that each digit has to get 1,000 times bigger. So why don't I just move the amount of zeros that are in the problem? For example, the 7, which is now in the thousands place, will jump 1, 2, 3 places to the left, because that's what numbers get bigger, and place the 7 there. The 2, which is in the hundreds spot, will move 1, 2, 3 to the hundred thousands place. The 3, which is now in the tens place, will move 1, 2, 3 to the 10,000s place. And the 4 will move 1, 2, 3 to the thousands place. And I can just fill these in with zeros. So how many stirs? 7,234,000 stirs. There's no need for this.